Okay, I think it is. All right, so I just wanted to come on and talk to you guys a little bit about the sine curve, how to graph it, and some of the parts. So I'm going to be spreading this out over a couple of days. So first thing I want you to know is that, let's see, there we go. This is the general form, the general equation of a sine curve. Okay, you've seen a couple other videos. Hopefully you kind of grasp how the sine curve is created, where it's coming from. So we're just going to be moving around the unit circle and then graphing the y coordinate as we move around, okay? So if you take a look at my graph here, let's see if I can zoom in on this. No, I can't. Let's undo that. Well, hopefully you can see on your graph, or I'm linking this sheet so you can look at the sheet. Take a look at the x coordinates right here, what we have. We have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. Okay, 2 pi, if you remember, is a full circle, right? So if you start at 0 on the unit circle and you go all the way around, you've gone 2 pi radians. That's one full circle. So half of a circle is pi. That makes sense. That's 180 degrees, right? A fourth of a circle is pi over 2, right? Because it would be half of a half. So pi over 2 is really like 90 degrees. Pi is 180 degrees. 3 pi over 2, or 1.5 pi, that's like 270. And then all the way back around to 2 pi finishes out our complete circle. Okay? So when we are graphing, we're going to be taking a look at a couple of different things. So if this is my general form, this value right here, A, okay, that's something that we refer to as the amplitude of the graph. The amplitude refers to how high and how low the values are, okay, our y values. So you'll see in a minute when that sort of plays out. For today, we're going to leave b as 0. So you have to use b is going to help you figure out the period of your graph. And the period of the graph is basically how long does it take for my graph to complete one full cycle. So if you remember from the videos from before, the sine curve kind of looks like this, right? And it just keeps oscillating back and forth, back and forth, back and forth. So the period refers to how long does it take for me to, so if this is my starting point, how long does it take for the whole cycle to happen? So a sine cycle, it goes up, all the way down, and then right back. So if you take a look at just that piece, that's one full cycle of the sine curve. And then it just keeps happening, right? So if I start at this point, I go up, all the way down, and come back. Okay?
Mommy.
Hi, honey.
Mommy.
Yes, baby.
Where's it give you like? Please.
Can you go see Daddy for that?
Okay.
Okay, thank you. Okay, sorry. So anyway, we were doing another full cycle, okay, and then we do it again, and it just keeps going on forever and ever and ever and ever. So the period refers to how long does it take for that one full cycle to happen, okay? So for today, we're going to leave the period at 2 pi for all of them. So we're going to talk more about the period in a future lesson and video. So for today, we're really just going to focus on this amplitude and changing that. Okay, so let me show you how to graph the basic sine curve. I'm going to try and erase this stuff. Okay, so let's get rid of all this. Okay. All right, let's stick with green. That is my favorite color. All right, so the sine curve, if you start at 0, okay, it's going to start the sine. Oh, whoops, hold on. I gotta click this button. Okay, sorry. So starting at 0 radians, the sine of 0 is 0, okay? And then as we continue on throughout, the sine of pi over 2 is actually 1. Oh, this is really hard to make it accurate. Okay, so that's supposed to be at 1. Then when you get to pi, it's back at 0. 3 pi over 2, it dips down to -1. And then at 2 pi, it comes back to 0. Okay, so again, you saw a couple videos of how this was created. So if you just take a look at what the sine of pi over 2 is, what's the sine of pi, sine of 3 pi over 2, sine of 2 pi, you're going to get all of these values like you see here. So when we connect these dots with a nice, oh, come on. It's not, there we go. Connect these dots with the nice smooth curve. And it doesn't actually stop there, right? If I kept, excuse me, kept going around my circle past 2 pi, it's just going to come right back up to 1. It's just going to keep going, right? So it would just keep doing that same oscillating pattern forever and ever and ever. So that's just going to keep going. Same thing happens over here in the negative side. Okay, so as this continues in the negative direction, it's going to do the same thing. It's just going to keep doing this, oscillating forever and ever and ever and ever. Okay, so that's how you graph the basic sine curve, where the amplitude is 1, the period is 2 pi, nothing has changed. Okay, so now if we take a look at the examples down below, I have changed something. I've changed the number in front of sine. So that means that the amplitude is now different. So what does that mean? Remember, the amplitude is how high and how low my graph goes. So in this first one, the amplitude was just 1. I'm just bouncing around between +1 and -1. Okay, so I'm only ever going 1 unit, if you will, above or below the x-axis. So that's why my amplitude is 1. If you look at number 2, the amplitude is 3. So how is that going to change my graph? It's going to look exactly like this graph right here. It's just that instead of bouncing between +1 and -1, it's going to bounce between +3 and -3. So it's going to be the same graph, just kind of stretched to look taller. Okay, but it's still going to have the same period. So to do one full cycle of my sine curve, starting at the origin and going up and then going down and coming back, it's still going to land at 2 pi. Okay, so let's try it out. So I'm still going to start at the origin. Okay, that's how I know it's a sine curve. Sine curves always start at the origin unless I'm doing a shift, which again we'll talk about later. So now when I hit pi over 2, normally I'd be at 1, but now I'm going to be at 3 because that's my new amplitude. When I hit pi, I'm still at 0. 3 pi over 2 now goes down to -3. And then 2 pi comes back to 0. Okay, so this is what this graph looks like. Okay, and then again, it just keeps going, right? It's just going to bounce between +3 and -3 forever. So that's going to keep going. You're going to keep going this way. I didn't do that very well. But that's it. That's the only thing that changes. So if you have a number in front of sine, that's going to tell you how high or how low you're going. So number 4, right? This one is going to be the exact same thing. It's just that I'm only going up to +2 and down to -2. So 3 over here, this one's actually going to look like I took the graph and sort of squashed it. It's going to look flatter. The highest I'll ever get is a half, and then I'll go down to -1/2. So this one's going to look, you know, really kind of short and squished. Okay, and then 5 is going to be our tallest one of all because the amplitude's 4. So I'm going to go all the way up to +4 and then all the way back down to -4. Okay, so give those a shot. I included the answers right on here so you can check them when you're done. But please do give it an honest effort. You will be seeing these in future math courses, I'm sure. So it's worth getting a little bit of exposure to this, okay? So later we'll look at cosine curves and also changing the period, because it's not always going to be 2 pi. All right, and we'll talk about that later.